Welcome to another Directions Mag Geospatial webinar, today sponsored by Pitney Bowes and Carem. I'm Barbary Duke, Managing Editor here at Directions Mag with our assistant producer, Lynette Qualia. If you have any questions about your connection, just drop us a note in the chat. We'll do our best to help you. For those of you who don't know Directions Mag, we have been a respected source of information and news for more than 20 years. We encourage you to read our feature articles, daily news, and of course attend more webinars at directionsmag.com. We're standing by to take your questions today. Type those into the question box at any time during the webinar. We're going to do our best to answer as many questions as possible during our Q&A time today. We are recording, so do keep an eye on your inbox in the coming days for that link. If you see something you like on the screen, you can always click that little camera icon. And we appreciate your opinion on our polls and the post-webinar survey happening today. So we are excited to learn more about incredibly rich data resources for your GIS projects today. We are honored to have Brianna Brown and Colin Madison from Pitney Bowes back with us. They are joined by Jan Trudeau from Carem. Welcome, everyone. We are excited to learn more about these great data resources and plugging them into our workflows. Brianna, over to you.
Great, thank you, Barbary. So hi, everyone. My name is Brianna Brown, and I'm a data product manager at Pitney Bowes. So thank you for joining the webinar. By now, I'm sure you're familiar with what we call the knowledge fabric at Pitney Bowes, which leverages our unique knowledge and legacy to bring forward the realization that everyone, every place, everything is addressable. So for nearly 100 years, we've been verifying global addresses, identifying and locating people and places and things that matter, and helping to enable various business processes throughout various use cases and verticals. So now we're going to be able to show you today how we handle incredible amounts of data and find relationships within that data to help you solve those complex business problems. So as I mentioned, the knowledge fabric brings forward that idea about everyone, every place, and everything being addressable. And for our data line of business, what that means is taking an address and doing all of the things to make it more usable. So things like standardizing, cleansing, geocoding it, and then adding in contextual information to solve problems that our clients care about. So whether that's insurance information, maybe something related to finance, or another vertically focused application. And understanding location information, like adding information about a property or describing a location itself, really helps to enrich processes like risk models, territory analysis, site selection, things like that we know a lot of our customers depend on day to day. So when we think about proximity and look at nearby information, all of those different factors are components that we would add in and add into the context around an address and allow our users to gain insights and make better business decisions with more confidence. We can even get more granular and find out specifically who or what is at an address. So we can look at an address, see who lives there and what their social media activity is like so that we can find out more about their lifestyle. So right now we are building our portfolio to bridge that gap between the physical and digital worlds with data. So at Pitney Bowes, we source the best of the best to develop data sets of the highest quality. And we do the hard work of cleansing and standardizing that data so that you can get right down to your analysis and problem solving. Our curated data is fit for purpose across industries, and it's available for you to sample on our software and data marketplace, which you can explore at pb.com/SDM. There will be a link later in this presentation, and we'll send it out as well. But there, I'd like to pause, and we can start our first poll. So, Barbary, if you wouldn't mind.
Yeah, absolutely. So we'd like to get an idea of how much time do you estimate you spend on data prep before analysis? Maybe less than an hour, more than an hour, more than 2 hours. I know that's a universal challenge for many of us working with data. So Your top choice. More than 2, more than 1, about an hour, less than an hour. All right. Looks like we've got a good idea here. So we'll share these results real quickly. It looks like 42% are spending more than 2 hours, coming in second place with more than 1 hour. So thanks for sharing that with us, folks. And Brianna, back to you.
Yeah, thanks everyone. I know data prep can definitely take a lot of time, so it's good to hear what everyone has to say about that. So moving along, through our unique identifier for an address, which we call the PB key, we enable our users to use our curated data sets together for a smooth and streamlined experience. And the breadth and depth of our data allows you to have a one-stop shop to get essential data on people, places, and things, and what that means for your organization. So as you'll see in these demos, our data sets all work together to solve business problems and can be used in the system of your choice, whether that's a location intelligence tool or a BI tool. Our data is agnostic and you can use it in whatever system you want. And just to look at our portfolio very quickly, so no single competitor can match what we have with our complete data product offering. Our portfolio is made up of hundreds of on-the-shelf data products representing business, geographic, and industry-specific data. We have global coverage for over 250 countries and territories, and we're the only company with a century's worth of knowledge on the connection between an address, a location, and digital identity, which you can use for actionable insight. But all that said, let's get to the fun stuff and look at the data. So let me just queue up the video here and I will hand it off to Colin.
Thank you. So I'll let the video start. So here we have an open QGIS project, an open source GIS tool. For best practices, we'll add in a base map to give more context to the demonstration. And in this case, we'll use the open source theme and use an OpenStreetMap base map. The retail use case we'll explore in this demonstration is customer analytics and customer acquisition. Through the lens of sample customer data, geodemographic segmentation, points of interest, and commercial geofences, we'll see how retailers analyze their data to apply geofences to deliver their message to the right person at the right time. So now that the base map is loaded, we've actually added in a customer file. Unfortunately, a lot of these customers have only trialed our product. So as we can see, these customers fall into 3 buckets. Those that have trialed the product, likely buyers, and then there's 2 categories of actual paying customers that are either standard or premium subscribers. So if we can convert another 5% of these customers that have trialed but not yet subscribed, this campaign will be a success. We're going to run a table query against the customer list and extract only those that are interested but haven't yet committed to a subscription. And we'll save that trial campaign file for later use. So to do that, we're going to run a table query and select out each of the trial users. Here we can see that select by attribute, and using the subscription type and typing in trial, we're going to be able to query out those specific locations and then use those further. So now we can see the table query, and now we just need to save that file. We'll go ahead and do a quick save so we have that data to run further analysis on. So once we're done with that part of it, what we're going to do is take a look at the Cameo data. And so what and there we can see those actual points. So here we can see that subset. Now that we've got that bit of data, we want to take a look at the Cameo data. And that's going to be a geodemographic segmentation product that segments the population into income and life mode categories using an alphanumeric matrix. So a 1A household is going to be at the top of the income scale and fall into the youngest of the household types, and a 10E would represent the opposite end of the spectrum, being the lowest income and the oldest household types. Retailers typically join their customer data to demographics and segmentation to understand their sales by SKU, with different segments tailored, and store with different segments to customers to tailor their messaging, product mix, and product placement. Once we bring in the Cameo data, it's useful to adjust the styling to visualize the granularity of the data. So we'll style that data along the income only, just to simplify the color scheme. And this Cameo data is actually captured at the block group level and built upon raw census demographic information. So now we're able to see that, and I've actually gone in and restyled the trial points just to make them easier and to create a little bit better context and contrast between those two data sets. So now that we've got those two data sets pulled in, let's take a look at some of the Cameo data. So we'll zoom in on a specific area, take a look at a neighborhood, and take a look at one of those block groups to see what kind of information is contained in that Cameo data. So now we can see this block group has a population of 316 and is both young and affluent as the 2A, and that's actually called the skyscraping nouveau riche description of that segment. There's only 215 households for those 316 people. So over half those households are singles, and we can see low scores for both presence of children and financial stress. So that just gives an idea of some of the value and some of the data behind that Cameo data set. Now that we've had a look at the customer data and the geodemographic segmentation, we'll bring in points of interest data. And this will take a few seconds to process and load. Once loaded, you'll see points of interest are everywhere in San Francisco. Points of interest are commonly thought of as businesses, but they can also be public institutions, parks, schools, airports, ATMs, bus stops. For this particular use case, we're going to be looking at some of the information around brand names and the types of businesses, specifically large retailers, since we're going to want to partner with those. And using that brand name, we'll be able to filter the whole ecosystem of commerce down to the specific brands we intend to partner with to leverage for this campaign. So what we've done here is added in a delimited text file of points of interest with point level, meaning structure rather than street interpolated accuracy. And these are immediately able to be visualized on the map. Since more and more retailers engage with their customers through applications and consumers expect tailored experiences, geofences have become a popular way to deliver advertisements when we're on the go. If you've ever received a Starbucks discount while walking past a Starbucks, it's not magic, but rather brand smart use of your phone to deliver a better experience. And to that end, we'll query out Starbucks locations for this area. For geo-targeting and geo-advertising, using a buffer around a point of interest is a very popular way to deliver that now anticipated pumpkin latte offer around Thanksgiving season. So let's adjust the symbology and color to correspond with the brand. And right now we'll run that spatial query for Starbucks so we can see that selecting brand name and doing select by attribute again, we'll be able to pull out the Starbucks locations. It's going to run a quick process, and then we'll save those Starbucks locations and bring those back into the map. And there we go. Now we're doing the save as, and we'll have that data for our campaign. So based on the demographic diversity of our trial members, we saw that we had folks in that skyscraping nouveau riche. We also have a lot of customers that are further down the income scale, and they're going to have different tastes and affinities. So based on that, we're going to want to select another brand to partner with that is more appealing to those middle and lower income customers. And for this use case, we'll actually run a query for CVS locations. I'm running a little bit ahead. So the CVS locations are going to be the same query, again, pulling on that brand name, typing in CVS, and then saving those locations out. We'll be able to take a look at those as an additional brand. So while we can use the CVS points for the targeting, we're going to actually use another data set for geofencing the results of this campaign. And so we're going to add in an additional product here in a moment, a new Pitney Bowes data product called Commercial Geofences Parcels. And this is going to be used to increase the accuracy of measuring in-store visits to determine campaign effectiveness. And what commercial geofences do is they combine the point of interest attribution that we're seeing in the Starbucks and CVS locations with the polygon shape of the parcel that location is built on. And that data set contains over 10 million polygons for those businesses across the United States. Here we're just looking at that San Francisco sample. So once we bring those in, we'll be able to see the actual footprints of the CVS locations. Right now the CVS is being saved. So here we can see it's very dense in terms of points of interest. Now we'll take a look, we'll adjust the style of the CVS locations to make them pop out against this OpenStreetMap base map. And there we go. Now the CVS locations are in, and adjusting the styling, I'll make it a little bit larger and use some red color to match the CVS branding. So now we can see those CVS locations in this particular neighborhood up north of Powell Street. And so now we're going to actually bring in those commercial geofences to take a look at those as well. So I'll add another piece of data. We'll add in this shapefile. And it's worth mentioning right now that the commercial geofences are available as shapefiles as well as well-known text. So this data is available in for GIS tools as well as for BI tools and databases. So it will work in any sort of manner. So here we can see those commercial geofences coming in, and we'll see that brand name yet again. We'll search for CVS and then extract those locations, those geofences from the data set, and save those to run our campaign against and to measure the campaign afterwards. So now we've queried those. Now we'll just save those selected features as our CVS geofences. With that, we'll turn off those commercial geofences to be able to see a little bit better the specific locations we're interested in. And we'll adjust the symbology there to make it easier to see. Again, matching red for the CVS brand. And so now we'll have those red locations, and we can see all those CVSs in this portion of San Francisco. So with that, we have the data we need to execute and measure our trial campaign. And with that, I will pass it back to you, Brianna.
Great, yeah, thanks, Colin. So before we get to the next demo, I wanted to pose another poll question.
So we're curious about what GIS program you prefer to use. Maybe that's MapInfo Pro, ArcGIS, QGIS, or you have another favorite. All right. So I think we've got a pretty good idea here. So let's share those results real quickly. Almost half are using ArcGIS, and then coming in a good second is MapInfo Pro, and some other folks out there also using QGIS. All right. Thanks.
Yeah, thanks everyone. Yeah, so I mean, this demo that Colin just went through, this was in QGIS, but you'll see those other systems mentioned and shown later today. Perfect. So with that, I'll hand it off to Jan.
Well, thank you, Brianna. Thank you, Colin, for this presentation. So good afternoon, everyone. Just to add some context, so Corem has been a long-time partner with PB for over 20 years now. And today we'll be really showcasing Esri's compatible PB locator. So what we've actually did is we downloaded the San Francisco sample data set from Pitney Bowes Software and Data Marketplace. And this is basically provides clients with an easy access to all of Pitney Bowes data and software products through a single centralized platform. And then once we've downloaded it, we actually uploaded all of that, the address fabric and the world point of interest on ArcGIS Online. So now you're seeing really ArcGIS Online here. First off, what I want to showcase is really by inputting a value, just showcase the two VARs locators that are registered here into the ArcGIS Online. So you can see all spectrum and in ArcGIS World, the default ArcGIS geocoder. So to add a new geocoder or locator, what you do is you go under your organization configuration panel under utility services, and in the geocoding side, there's a button add locator. So in this case, it's going to edit the spectrum one. So what we've done is we basically have provided the endpoint to that Pitney Bowes locator. Okay, so it's Esri compatible, so you can actually just simply register this. Note that it is in this demo, it is set as the default one. It's the first one in the list. So now back to the actual ArcGIS Online. We have the world points of interest that you can see on the map, as well as the address fabric, the PB address fabric. So in this case, we're going to start by searching 536 Golden Gate Avenue, and we're going to select the spectrum results. As you can see, it zooms us directly to the location, and we're getting a zip+4 code value or return value. So now I'm selecting the address fabric. I don't want you guys to be sick with all these points and labels. So we're going to do the same search, but now this time we're going to select the ArcGIS geocoder. Now by redoing that same search, you can see that now we're actually positioned at the street level. So right away, you're seeing a huge difference between the PB locator and the Esri one. Now, I'm going to do a couple of other searches like this, like with this address. Again, because we had selected the Esri as the default one, it actually showed, again, to the street level. Now, by selecting the spectrum level, redoing that same search, you're getting really your search at the rooftop level, which is really more accurate. Now, to give you a better appreciation, I enabled the imagery layer. It shows you the building outline on the image. So you can see that we are really on the rooftop level. And this is, by the way, a POI that we're looking at. Now we're going to search for just a normal address. And this address, again, using the Esri locator, actually brings us directly at the street level. But selecting the spectrum one, you can see it actually goes and falls directly on that rooftop level. So you're again, I think, getting the picture that yes, the PB locator will bring you that better accuracy. Now, moving on, I mean, the next portion is I'm going to show over the topographic map. Really, what we're going to do is drag and drop a CSV file over ArcGIS map here. And basically, we're going to geocode over 500 addresses. So that file has over 500 addresses. So when you drag and drop, you basically decide what you want to do. So I want to basically geocode the addresses using the locator that you've registered. In this case, we're going to use Spectrum. So just to show you how transparent and how easy it is to use this, we're going to match all the fields from the CSV file to the field names, and then we're going to run it. Now, what you're getting is you could change the styles as with any Esri layers. You could set some semantics and stuff like that. We're going to be dismissing this just for demo purposes, but just note that you can actually do that. So you saw quickly the results of all the addresses really are being displayed here. And then what I'm going to do is enable the address fabric, which is basically using the Esri Geo services. As you can see, it comes in chunks of GeoJSON. And it basically shows you how easy it is to use the PB locator. Now, shifting gear and going back on the desktop, so ArcGIS Pro here, you can see if I go under the locators, you're going to see our Spectrum locator that will register into our organization. So it's using, again, that configuration we've set in the ArcGIS Online site. And anyone within the organization can now use this. Looking at the data sources, we have the world point POIs, and then we will also see our address fabric coming through. Just note that a desktop has way more capabilities, way more power, so you could probably set different rules. In this case, we changed kind of the grouping levels for those POIs that Colin was showing in the previous demo. Now, what I want to showcase on a desktop side is how, again, everything is transparent to the end user, do a geoprocessing, and in this case, do a geocode of addresses. I'm going to do the same exercise to choose my CSV file, which contains all these addresses, over 500 in this case. Basically, select my locator that I registered again on ArcGIS Online, and we'll match the columns into my CSV file to the field names required. And once I've done that, select my output feature class or a geofile database, and then basically click on Run. Quickly, you're going to see that you get your results. So what I'm going to do is just to showcase, remove the world POI so that you don't get mistaken. And right away, you're seeing the result of the PB locator. So, I mean, you guys on the webinar, you said half of you are using Esri. Well, this is a good way of getting better, accurate results from the geocoding service. And then you're seeing basically the attributes being shown, basically your results that you're getting from the PB locator service. So, I mean, a couple of advantages of using the PB locator. Better accuracy, you've seen rooftop versus street level. So this can bring you better ROI from if you're doing some advanced planning on the utility side or doing some better quotes from an insurance standpoint or site selections. But ultimately, the PB locator is transparent to every user. There's no transaction cost because you're not using credit. So you're basically using that so you can batch process millions. And to this, I will pass it back to Brianna. Thank you very much for assisting today.
Yeah, thank you so much, Jan. I want to pause there again to pose another poll question, this time about geocoding after we had that great demo of PB locator.
Yeah. So what sort of geocoding level is required to meet your needs? Street, rooftop, centroid, or perhaps some other things that are a priority? Oh, and we have a clear winner. At 58%, the rooftop level is the most popular. So fantastic. Not a big surprise.
That might be the case.
Yeah. We certainly want as accurate as possible in GIS. All right, Brianna, back over to you for the next.
Great, thanks. So I'm actually going to hand it off to Colin so he can show us some data in MI Pro.
Thank you, Brianna. So here we have open Map Info Pro workspace. And to give some more context to the demonstration, we'll add in one of the Pitney Bowes pre-configured base maps. And today we'll explore a use case we're seeing a lot for the real estate industry, and we'll show how to use school information, neighborhoods, and points of interest to build context around markets and help individuals and families find homes that suit the way they live. So now that the base map is loaded, we'll use the Open tab, bring in a new table, and select some data to add in. So the first thing we're going to bring in is going to be the school layer. And we'll first need to zoom in on that region and pull open the Info tab to see some information about the schools. So in the Info dialog, we'll be able to see clean standardized data elements describing the nature of the school. And right now we'll use that Info tab. We'll see that on the left side of the screen. And there we'll be able to see stuff like descriptions of things such as the type of the school, the name of the school, whether it's public or private. Here we've chosen a couple. We see the name. It's got an object ID and a location. So now we've been able to take a look at one of the schools from that school set. The next thing we want to take a look at is a really important part for real estate, and that's the school attendance zone. So we'll bring that in and we'll style this data for visualization. Right now it's we can see the entire San Francisco area as well as all those sub areas beneath it. So we're all familiar with the important school scores and quality plays on real estate decisions. And this kind of data is central to most home buying decisions and an expectation of buyers. So we'll see which schools fall inside the attendance zones. And there we can see specialties of schools, high schools, middle schools, elementary schools. So those are all popping up within that school attendance zone data. The next thing we'll take a look at is neighborhood boundaries. And we'll add in the neighborhood boundaries and style those appropriately. Neighborhood boundaries come nested in 3 sizes. macro neighborhoods, neighborhoods, and sub-neighborhoods to describe the complex ways in which we live today. We have neighborhood data globally focused on metro areas. So the neighborhoods are necessary because cities are often too large to understand, to decipher, and zip codes change every month. And so by using those neighborhoods, we can see a little bit more about this location. And I've styled that so we can see it against the school attendance zones. And so purchasing in a prestigious neighborhood can often influence appreciation of the home, and it can bolster home value in a down market. So in addition to those school scores, people want to be in the right neighborhood for their protecting their investment. So we can see the macro neighborhoods such as Southwest San Francisco in that upper left-hand side, as well as Outer Sunset, which is what people that live in San Francisco would know that area as. We'll actually dive in a little bit deeper on that neighborhood in a few moments, but right now what we'll do is, having looked at the school information and the neighborhood information, we'll take a look at some shopping areas. And so many people rely on public transit to get to work, school, and around town, and they want to know what kinds of stores they're going to walk past on a daily basis for things like groceries, coffee, the pharmacy, etc. So shopping areas describe both the shopping centers as well as shopping districts, and that in this context are populated by a mix of restaurants, cafes, boutique shops. So here we can see in that dark blue those neighborhoods, those shopping areas, and those shopping districts. Now we'll take a look at some of the point of interest data, and I've just added in the drugstores, and so those represent local drugstores. So being able to see what you may walk past on your commute to work, on your commute to the bus or the BART in San Francisco, and knowing that you'll have easy access to pharmacy and daily needs. So next we'll take a look at restaurants and bars, and so what we're actually looking at is eating places and drinking places. So I'm going to add that in. So that kind of represents both the sit-down restaurants, fast food restaurants, as well as nightlife type things, wine bars, regular bars, things of that nature, to see what kind of activities and amenities are available. And for families with high school and college-age kids still at home, as well as those that are part of the growing work-from-home segment, having nearby coffee shops for socializing, as well as for backup Wi-Fi, has become really essential. And so here we'll take a look at coffee shops in San Francisco. So these are all subsets of the data pulled from the points of interest that we touched on in the first two demonstrations. And so we'll bring in those coffee shops and style those, make them a brown so they look like coffee, and we'll be able to see those all in that context. So now that we've taken a look at a few of the different data sets and gotten an idea of the schools, the retail, and the daily needs of the of folks, we're going to want to next take a look at the inventory of available homes for this particular district, and to sort of see how close they are to these particular amenities, and use that as a ranking criteria to start deciding which home we're likely to purchase. So with that, I'm going to bring in the amenities, sorry, not the amenities, the housing inventory, and we'll actually take a look at that and zoom in on those locations. So we're bringing in those available locations. We can see we're going to turn those latitudes and longitudes into points, and then style those so that they're a little bit easier to see against this base map. And so here we can see there's a little cluster in that Sunset District of yellow, and there's some pharmacies, and so those would be the ideal locations nearest that shopping and that retail boutique location. So with that, we've been able to take a look at available properties against some of the key criteria. And at this point, we would like to take another poll question. So I'm going to pass it back to Brianna and Barbary.
Yes.
Yeah, thanks, Colin.
So we're looking at what file format you prefer to use for analyses like this. I know lots of people have favorites or things that they can access more easily. And it looks like another clear winner, and that is over half prefer a shape file, and coming in second at 25% is tab. I'm gonna another tiny percent, either text or some other file formats. All right. Thanks, folks.
Great, yeah, thanks. All right, so next we're gonna stick with the San Francisco area, but this time we're gonna be using Spectrum Spatial. So let's imagine that we're an accounting firm looking to open a new office in the area, and we have one potential site located, but we want to learn more about it. So I'm going to type in that address, and we're going to zoom to it and geocode it. There you can see it on the map. Some aerial imagery, but as I mentioned, we need to see, understand more information. So we're going to pull in the parcel boundary. That way we can see what the actual property looks like. There you can see we zoomed in, that yellow line symbolizes the boundaries of the property itself. That way we just understand a bit more about this property before we move along. But next, we're going to pull in points of interest data, as we've been showing in the other demos, and we're going to symbolize based on trade division. So according to this symbology and the legend on the side, you can see a lot of these businesses in the area are similar to an accounting type business. So if we look at the information on the left here, we can see there's a law office located within this building already. Scroll a little bit more, get some more information. We also see there's a consulting firm. So this would probably be a good fit for an accounting firm to move into. We'll also use points of interest to better understand what other businesses are in the area. So it looks like the building I've selected now is a CVS. That might be desirable for people working in the office to work near. That way they can run errands if they need to. At lunchtime or whatever. And then we can also see there's a bakery nearby, which might be good to go get a cup of coffee or lunch. So again, it's just really helpful to have that points of interest information to see what's going on in the area. But perhaps more important to this particular firm's search for a new office was their requirement that the new office be fiber lit. So if the firm itself doesn't have to incur that cost, they've done their research and found that they would probably spend 40% more in acquiring this office space if the building is not already set up for fiber. So they need to look more at telecommunications information to see if this building fits their technical needs. They know it works from a points of interest point of view, and they like the area and the property, but they really need to know how it would be connected. So to better understand that, I'm going to turn off points of interest. That way we don't clutter the map, and I'm going to put fiber routes, a line feature data set, which shows network coverage for more than 850 carriers across the US. We'll zoom out a little. We can see that the fiber coverage for all of San Francisco. If we zoom in a little more again, we can see that the building in question is actually in a pretty good spot for this requirement. So that would definitely be helpful. What we need to do next, though, is understand if the building itself is fiber lit. It might be near those fiber lines, but if it's not set up itself, that would be that extra 40% cost. So we can see here, this building, there's that address again, 55 2nd Street, is again fiber lit, and we can also scroll through and see what carriers are actually supported through that. So that might also make their decision to move into this office space easier if there's a specific carrier that they had in mind. So this type of information is obviously important for the accounting firm, but it would also be important for the real estate firm that's tasked with selling that office space, because they need to make sure it's priced appropriately. So the fiber connectivity really does determine that. There might be some other factors that the real estate firm would want to take into account when pricing this space. They might want to pull in cell tower locations to better understand cell phone reception in the area, and then that could even affect the price of the space. So here I've pulled in those cell towers. We can click on them and get some more attribution, which again helps that pricing decision. So here you can see where it's located, what type of cell tower it is, anything that will help make sure that the real estate firm prices that space appropriately, keeping all attributes in mind. That way they don't miss out on any income. But maybe more helpful would be to look at some of the other properties in the area and their values. So now I've turned on property attribute information, and you can see the legend on the side with the different property values and all of the points in the area. That way we can get a better idea of just prices in the area. But I want to re-geocode our address so that way we can look and see how we're priced and how that might compare to this general market. So if I scroll through our property attribute data here on the left, you can see there's quite a bit of attribution there, but we have our the property value calculated, and we can see how that compares to other properties in the area, which will just better help that real estate firm make sure it's priced appropriately. So that being said, telco information, in addition to just property information and that points of interest, can really help make decisions not only for businesses that are looking to expand, but also companies that are looking for the right information for pricing their properties. So again, that was shown in Spectrum Spatial, but I'd like to have another poll right now.
So what was the last data purchase you made? Was that consumer data, address data, boundary data, demographics data, or something other than that? So that's consumer, address, boundaries, or demographics. And again, this answer is not really surprising me. So let's share this with everyone, the whole class. 43% demographics data, and then coming in second, boundary and other. So.
Yeah, I'm not surprised either. Demographics data, where people are affects pretty much every business, every industry. So like you, Barbary, I'm not surprised. But with that, I will hand it off to Colin for one last demo, this time showing our data in Tableau.
All right, thanks, Brianna. So this is Colin again, and this time we'll be looking at Pitney Bowes data inside of Tableau. For those of you that aren't familiar with Tableau, it is a business intelligence application. And in this example, we're going to walk through a common insurance use case, using use case segmenting property policies and evaluating the risks surrounding each of these members' homes. I've just added in the Cameo geodemographic segmentation we looked at earlier, the data that separates households by income and life mode, meaning where a household falls on the spectrum of young to old. And you'll notice that in Tableau has the ability to read a variety of spatial data formats. So shapefiles, which were the most popular per the poll, tab files, KML, as well as GeoJSON. So let's take a look at how quick and easy the data is ingested and displayed. So here we're already mapping that data, and here we can see the number of households by block group as I hover over. And next, I'm going to add in another element onto the color palette. There we'll be able to see a thematic map very quickly and easily, and so we can see both households as well as the income focus. So being able to see a couple of variables very quickly mapped from that data that we brought in. Tableau is best known for allowing data analysts to analyze and visualize many data sources through joins. What you may not have known is that in addition to tabular joins, Tableau also supports spatial joins, as well as we'll see here when we join in our policies enforced, which is a point file, and we'll be joining that to the block group level geodemographics by running an intersect. So here we can see that intersect being run, and there's a match. Geometry intersects geometry, so that's running a simple point and polygon, and so there we're able to bring those two data sets together, and we'll be able to, again, map and visualize those. So here we can see the number of policies by block group, and just give me a moment to zoom in here on those locations. I'm going to use graduated circles so we can see where there are more policies. So you just saw me hover over that 99 policies, 24 policies. So here we can very quickly see the number of policies by block group area by joining those two data sets together. At this point, we've shown the power of spatially joining two differing types of data in Tableau on geometry only, running a simple point and polygon operation. And we see a lot of folks using the data in this way. Now we want to take a look at some additional elements to determine the risk of each policy by joining on the unique PB key Brianna mentioned earlier. So to execute this workflow, we'll bring in some additional risk and boundary data sets that all share that unique key. So we've created a PB key for 188 million addresses in the United States. We also have Address Fabric for Canada, and this data set is called the Address Fabric. What we're going to be looking at is related to that flat file, and that's what you're seeing here is the geo-enrichment boundaries. And the geo-enrichment boundaries lookup is a geo-enrichment data set associating Pitney Bowes proprietary unique and persistent identifier PB key to the boundary IDs and the boundary names. The data set is created using Pitney Bowes location intelligence software to associate our location intelligence boundary data to our address fabric, which is the most comprehensive address data set on the market. And this pre-processed data means users don't need to perform complex geospatial processing to understand the relationships between an address and the boundaries within which it falls. With the geo-enrichment boundaries lookup, insights such as customer activity, school district, township administration are available through that simple lookup. The geo-enrichment boundaries lookup is database loadable, so it can be used in a system such as the one we're looking at here, Tableau. The next two data sets we're going to leverage are earthquake risk and wildfire risk. Since we're in San Francisco, those make the most sense in terms of risk data sets to look at. And so these data sets are also available at the address level and will be joined to the policies on PB key. So I'm bringing in some simple text files, joining those to those policies in force, and we're able to very quickly determine the risk at these individual locations. So this product combines, So yeah, the earthquake risk is going to contain historic earthquake information, as well as distance defaults, things of that nature, and create a score. Fire risk is going to incorporate things like distance to wild urban interface, so where the nearest woods are relative to the home, and or open space, as well as the slope and aspect of the location. Finally, we're going to add in the commercial geofences parcels. This product combines the attribution from the point of interest data set that's been a thread that's run throughout this entire demonstration with the polygon boundary or the polygon shape, as well as the elevation for risk analysis. So the reason for joining these commercial geofences product in is to identify where we have both commercial and residential policies in the same parcel or same building. What this is called is four-wall risk. So this is the idea that if my condo is above a restaurant with grease, fire hoods, etc., my condo is at higher risk of fire than if it was sharing a wall with an accounting office. So we've now seen the full spectrum of that analysis. With a little bit more time, I would have been able to publish this, but for the sake of time we've got together, I'm showing you the final product of what that analysis enabled me to do, which was turn all of those insurance layers and that information into a nice visualization and story that can be shared with other folks. And now we can be actually querying against those addresses of those policies in force and very easily seeing the crime scores, the flood scores, the weather, the hail, the fire, all of those kinds of pieces of information. And then finally, we can see the published final product on the Tableau site. So being able to show the powerful geospatial analysis you're all doing. With that, I will pass it back to Brianna. Thank you all.
Yeah, thanks everyone. We have one last poll about business intelligence.
So like earlier, we're curious about what sort of tools that you're using. Maybe that's Power BI, Tableau, Qlik, Cognos, or something else. So we'll give everybody a chance to fill in those. And while you are making those selections, want to remind everyone that at pb.com/SDM, you can get more information about the data that's being shared today. We'll share that with you via email as well, but that's an option for you. All right. So coming in first place is Power BI. Second place, 33% is other, so a mystery tool. And then in third place, Tableau at 30%. So nice even distribution across the board there.
Interesting. Yeah, thanks everyone for answering. So before I go into our conclusion, are there any questions that we want to talk about today?
Yeah, so we do have some coming in, and folks, if you have others that you would like us to ask, don't hesitate to go ahead and type those in. We'll do our best to get to as many as possible. So one of the questions coming in is, what is the difference between demographics and geodemographics?
Oh yeah, that's a good question. So demographics data is, your base population data that would be collected, say from something like a census. So how many males or females are within a certain area, or maybe it has more to do with age, economic status, things like that. Geodemographics is more of a segmentation tool, so aggregating all of that base demographic information into more of like lifestyle groups. So I think Colin had mentioned the nouveau riche and skyscrapers, or and that's a segmentation, or it's a type of person. So I'm not sure if Colin wants to add on anything to that, but that's the main differentiation between the two.
Yeah, I'd be happy to. So the demographics are going to be the raw variables, like the number of people of certain age categories or ethnicities, or gender distribution by a block group. The segmentation actually builds segments, so identifying what the primary household type for an area is. So it's kind of like it allows businesses to more quickly get to the answer they're looking for, and not go through the demographic analysis themselves.
Perfect. That makes a lot of good sense. So we've got a number of questions here related to the data itself. So we'll dive into those. Can you deliver data as a service instead of a file format, like you guys were mentioning?
Yeah, the answer to that is yes. We do have a lot of people that want to receive this data as a service. So that can be done as either an API call or through a batch process. So we support both of those.
Okay. And someone was interested in the FiberLit data and wanting to know where that comes from.
Yeah, so we source that data from a variety of providers. That's why you can see we have the majority of carriers we have over 850 carriers information listed there. So we do source that from a variety of carriers and providers, and that's where that telco data comes from.
So along those lines, with all those carriers, I'm guessing this question will make sense. What formats do you offer the data in?
Yeah, it depends on the data product. Across our portfolio, we offer shape files, tab files, text files, a variety. It really depends on the product and where we see customers for those products using it the most. So that's generally what I've seen.
I would add to that with a lot of the geo enrichment products and the point of interest data you guys saw today, those are available as flat file. So those are easy to load into a database, since they are simply a latitude and longitude, and many products now are able to recognize that spatial information.
Yeah, and the geo enrichment files as well are compatible with our Spectrum software. So that's its own file type, and you can use those in there as well.
Perfect. Someone was wondering what the PB key is. I know that you guys mentioned that. Maybe specifically, what is that?
Yeah, so the PB key is our unique identifier for an address. So, addresses are really complex and they change over time. A lot of times, say a street name will change, or maybe it'll, change to commemorate someone. One of the most popular address changes that happens in the U.S. is changing a street to Martin Luther King Boulevard or Avenue or what have you. So in that instance, an address will change, but really only in name. And so what our PB key does is it keeps a unique identifier on that specific address. That way, if there's any changes that happen, it doesn't affect your addressing data. And it just helps to link other data sets to each other. So for example, if you're geocoding something and you have, the PB key in there for that address, you can join another data set. Maybe it's demographics or boundary data or the telco data, based on that PB key. So that's your, common field that you're doing the join based on. It's really just a really strong data management tool, and it helps to bring together all those different types of data that we talked about.
That's great. Now, I know that you, while we're showing some information around San Francisco today, and those data sets about places certainly cover the entire nation, maybe more than that. But since we're talking about it being prepped and more specific, do you offer the data at a statewide level also, maybe already crunched down?
Yep, we offer data at a variety of levels. So you could get it at the nationwide level. If you're doing a countrywide analysis, you could also get it at a statewide level, and some of our data is offered at a county-wide level as well.
Wonderful. So our next is a question about the PB locator. And so what is the added value of using that particular tool if you already know that you're mostly Esri software using organization?
Yeah, that's a great question, Barbary. I mean, so like I've mentioned throughout the presentation, I guess you've seen quickly the rooftop level accuracy that you're getting from the PB locator. So that would be one of them. The other one would be it's transparent to the end user, and you configure once within your ArcGIS Online organization enterprise level, and then everyone within your organization can actually use it. And there's no cost. I mean, there's no, so a lot of Esri end users actually complain in the past about still complaining that there's transaction fees when you actually, or credit actually get consumed when using the Esri geocoder or locator. So in this case, using the PB locator, you could batch process millions and billions if you wanted to, without being too wary about the cost out of that.
And I would just add to what Jan said, the accuracy. We had a poll question on geocoding, and over half the people said that they need rooftop level geocoding. And so being able to move that point, that business, that risk that we looked at the end from the street to the actual building is going to change the risk value in terms of fire, in terms of flood, distance to coast with hurricanes. And so being very precise, even if it's 1 or 2%, if you're a large insurance company or reinsurer, it's really valuable to make sure that you're not underpricing or overpricing your policies. So just that extra accuracy is pretty critical.
Yeah, that's a great point, Colin.
Excellent. So I'm one last question for our panel here, and then we will remind everyone of where to get other information. So how can you access this pre-prepped data?
Yeah, so that's perfect, because I have the link here for where you can download our samples and play around with data on a map explorer. So it's pb.com/SDM. You'll see some preset geography samples, including San Francisco, which you saw today. And as I said, you can pull in data onto a map there as well if you just want to look at it really quickly without downloading. And then I also want to let you know that we have our Pitney Bowes knowledge communities at community.pitneybowes.com, which will allow you to engage with other users of software and data and see what they're up to, as well as our own experts. And you can talk to them about any questions that you might have. So I would highly recommend checking both of those sites out.
Wonderful. Well, thanks everyone for joining us today. We remember that you will get an email from us that will have a link to the recording and also a connection to an attendance certificate if you would like that as well. And of course, we encourage you to share the video with your friends if you think that it might be helpful to them. Appreciate you completing the brief survey on the way out. Special thanks to Brianna, Colin, and Jan for sharing their expertise and certainly their time today. And we hope that you will join us for more webinars here at Directions. Lots of great topics available for you, live and on demand. Have a great day. Tell a friend about the many resources at Pitney Bowes, Carem, and Directions Mag. Thanks, everybody.